Hello, in this video we're going to continue with the proof by induction. This example we have 1 over 1 times 2 plus 1 over 2 times 3 all the way to 1 over n times n plus 1 equal n over n plus 1. How to prove this? We're going to prove using the proof by induction, but first we have to write the 3 steps. If n equal 1, we have 1 over 1 times 2. Is this the same as 1 over n, which is 1, plus 1? This is equivalent to saying that 1/2 is the same as 1/2. So it's true for n equal to 1. So the same thing here, the second step, we're going to assume is true for n. And the third is to prove for n plus 1. That means we add one more term. You replace n by n plus 1, and this must equal to n plus 1 over n plus 2. So again, n, replace it with n plus 1. So as we see here, this is from the assumption, it's equal to n over n plus 1. And therefore, the left-hand side become as follows. Now we do the least common denominator, which is the n plus 1 times n plus 2 for both. So here we need to multiply the first term by n plus 2 plus 1. If we continue, we get n squared plus 2n plus 1 over n plus 1 n plus 2. If we factor the numerator, we get n plus 1 times n plus 2. If you factor the numerator, you get n plus 1 times n plus 1, and the denominator is n plus 1 over n plus 2. So if you cancel n plus 1, and because n is different than -1, because this is for all n greater or equal to 1, so n can never be 0, n can never be negative, and therefore this is never 0, so I could reduce this. So I end up with n plus 1 over n plus 2, which is the right hand side. And we're done with the proof. Now the conclusion is for all n greater or equal to 1, 1 over 1 times 2 plus all the way 1 over n times n plus 1 is equal to n over n plus 1. Let's see another example. Here we need to prove that 1 plus 4 squared plus all the way to 4 to the n is equal 4 to the n plus 1 minus 1 over 3. So again, we're going to try to write the 3 steps. So here are the 3 steps. So the first thing we do, we check for the smallest n, or the base n, which is n equal to 0. So as we see, 4 to the 0, is it equal to 4 to the 0 plus 1 minus 1 over 3? 4 to the 0 is 1, and here this is going to be 4 minus 1, which is 3 over 3, which is equal to 1. So the base n equals 0 checked. So for the n equals 0, it's checked. Now we're going to assume for all n greater or equal to 0 that 1 plus 4 all the way to 4 to the n is the same as 4 to the n plus 1 minus 1 over 3. And we're going to try to prove for the n plus 1. So we add one more term, n plus 1. We replace n with the n plus 1. So we become n plus 1, which is n plus 2 minus 1 over 3. Now we need to check that this left hand side equal to this right hand side. Okay, so from the assumption, we're going to replace 1 plus 4 plus all the way 4 to the n with 4 to the n plus 1 minus 1 over 3. Then plus 4 to the n plus 1. And if you do the least common denominator, you get 3. So 4 to the n plus 1 minus 1 plus 3 times 4 to the n plus 1. So here on the side, I'm going to just do this algebra. Where would be 4 to the n plus 1 plus 3 to the times 4 to the n plus 1. Again, similar to the example we've seen before, if this in the box called them x's, where would be x plus 3x? it is for x, so therefore it becomes 4 times 4 to the n plus 1. So this side becomes 4 times 4 to the n plus 1 minus 1 over 3. So the same base at the exponent, it becomes 4 to the n plus 1, which is n plus 2, minus 1 over 3. And this is the right hand side. So we went from left hand side and we end up equal to the right hand side. So whatever we needed to prove here we did, and therefore 1 plus 4 plus all the way to the 4 to the n is the same as 4 to the n plus 1 minus 1 over 3. So let's see this example. This one is a little bit different. It's asking us about divisibility. So a number, for example, divisible by 5, 35 is divisible by 5 because I could write 35 as 5 times 7. And the same as 40 and so on. You could write it as 5 times some other integer. So the same here. The question is asking, prove that 7 to the n minus 2 to the n is equal to 5m. And by the way, divisibility, we write it as like this. 7 to the n minus 2 to the n divisible by 5. This is the symbol of it. You may see something similar in your homework. So the question here is to prove, that 7 to the n minus 2 to the n equal 5m for all n greater or equal to 1. So right here we're going to write those 3 steps for the proof by induction. So here we have to check for n equal to 1, and then we have assume that for all n equal to so here we're going to have to check for n equal 1, and then we're going to assume for all n greater or equal to 1 that 7 to the n minus 2 to the n equal 5m, where m is integer. And we're going to need to prove that 7 to the n plus 1 minus 2 to the n plus 1 is equal to 5 times some other integer. I call it q. So let's check for n equal 1. Is 7 to the 1 minus 2 to the 1 equal 5 times something? Yeah, 7 minus 2 is 5 times 1. So it's checked. So to prove this left hand side, what I'm going to do is I'm going to start with the left hand side. So I say 7n times 7, because that is 7 to the n plus 1 minus 2 to the n times 2. It's equal. So right here, from the assumption, so I'm going to say so from the assumption, we have 7n is equal to 5m plus 2n. That means you add 2n to both sides here. So I replace this 7n with what I have from the assumption. So I'm going to replace 7 to the n with 5m plus 2n. And then times 7 minus 2 to the n times 2. And then I keep going until I find this side, the left hand side, equal to 5 times some other integer. I call it q. So what we have, if I distribute 7 times 5 and 7 times 2, I get 35m plus 7 times 2n minus 2 to the n times 2. So if I distribute 7 times 5 to the m is 35m, 7 times 2 to the n is 7 times 2 to the n, and then I have 2 minus 2 times 2 to the n. So it's the same way. Let's add the like terms. So you have 35m and 7 minus 2, that will give me 5 times 2 to the n. So as we see here, this is the same as 5 times 7m plus 2 to the n. So right here, the left hand side now, so the left hand side is equal to, which is all the way here, this 7n plus 1 minus 2 to the n. So the left hand side, which is 7 to the n plus 1 minus 2 to the n plus 1, is equal to 5 times 7m plus 2 to the n, which is 5 times, let's call it q. And then we end up with the right hand side. And therefore 7 to the n minus 2 to the n is divisible by 5. And for this next example, we're going to try to prove that for all n greater than or equal to 1, n to the third plus 2n is equal to 3, maybe m, where m is an integer. So again, what we're going to do, we're going to write the 3 steps. So we have the 3 steps. First, we need to check that it works or it's true for n equal 3. So the first thing we do, we check if it is true for n equal 1. So is 1 to the third plus 2 times 1 the same, which is 3 times 1 basically. So it works for n equal 1. Second thing, I assume that for all n greater or equal to 1, n to the third plus 2n equal 3m. And the third part, that's where we need to do the work, we prove that for n plus 1, meaning replace n with n plus 1, and this part is divisible by 3, that means it's equal to 3 times some r, where r is some integer. So there is many ways to solve for this different algebra. So what I'm going to do here, I'm going to take this left hand side, and if I factor n plus 1, I get n plus 1 quantity square plus 2, which is the same as n plus 1 times n squared plus 2n plus 1 plus 2. So if I add the like terms, we get n squared plus 2n plus 3. So the second thing what I'm going to do, I'm going to distribute. That means multiply n through and multiply 1 through. And add the like terms. So multiply n and multiply 1 and add the like terms. You get n to the third plus 3n squared plus 5n plus 3. Now we stop and think what we were doing. We're trying to get from left hand side to right hand side, which is 3 times r. So if I replace n to the third with 3m minus 2n from the assumption, so we have 3m minus 2n plus 3n squared plus 5n plus 3. And now add in the like terms again, we end up with 3m plus 3n squared plus 3n plus 3. Factoring 3 out, we get m plus n squared plus n plus 1. So basically this can be called r. So we end up with the right hand side, which is 3 times r. And therefore, for all n greater or equal to 1, n to the third plus 2n is divisible by 3. I hope this is helpful.